Have you ever wondered how birds fly, effortlessly darting through the sky? It's a fascinating spectacle, isn't it? This miracle of flight has captivated humans for centuries. But what's the science behind it? Let's delve a bit into aerodynamics, the study of how air moves around objects. Birds are the ultimate aerodynamic creatures, evolved with certain unique adaptations that make flight possible. Their bodies are lightweight, thanks to a hollow bone structure. They have feathers, not just for show, but they're actually a marvel of engineering. These feathers provide lift and reduce drag, enabling birds to slice through the air with ease. Bird flight isn't merely a physical process, though. It's a complex interplay of physics and biology. Birds need to understand wind patterns, adapt to changing weather, and even alter their flying techniques based on their environment. So flying is not just a simple act for birds, it's an intricate dance of physics and biology. Now that we understand the basics, let's delve deeper into the mechanics of flight. Flight, as we know it, is dictated by four primary forces: lift, weight, thrust, and drag. The first, lift, is generated when a bird flaps its wings, creating an upward force that counteracts the pull of gravity. This is balanced by weight, the downward force exerted by the bird's body mass. Thrust is the forward momentum that a bird generates by flapping its wings. On the other hand, drag is a backward force caused by air resistance against the bird's body. To minimize this, birds have evolved streamlined bodies and smooth feathers. But how do birds control their flight amid these forces? They do so by altering the shape of their wings and tail. By changing the angle and curvature of their wings, birds can adjust the amount of lift and thrust they produce, allowing them to navigate through the skies with precision. As you can see, every flap of a bird's wings is a complex calculation of these forces. But what about when birds soar and glide seemingly without effort, you might ask? Well, the answer lies in the clever use of thermal updrafts. Birds, especially large ones like eagles and vultures, utilize these warm, rising air currents to gain altitude without the need for exhaustive wing flapping. By circling within these invisible columns of air, they can ascend to great heights, almost like they're taking an elevator ride up into the sky. Once at an optimal height, birds can glide for long distances. They do this by adjusting their wing and body position to balance two key forces: lift and drag. Lift, generated by the air flowing over their wings, needs to exceed the bird's weight for it to rise. To glide, the bird adjusts its wings to reduce lift and increase drag, which is the resistance of the air against its body. So, the next time you see a bird soaring through the sky, you'll know it's not just nature's poetry, but also a marvel of science.